We will talk about a machine that presented us humans the information is received from the cosmos, and thought this knowledge will enable us to answer our past questions, or even make discoveries that will lead us to ask entire new questions we have never thought of before. The Giant Magellan Telescope. This enormous machine is planned to shed light on many topics or curious, such as galaxy research, exoplanet discovery, stellar evolution, and cosmology. But its primary goal is to investigate Earth-like worlds with a habitable atmosphere, and in light of these studies, the innumerable discoveries we have not even imagined asking about. 1. Technical specifications. This giant Magellan telescope, established in the Atacama Desert in northern Chile and abbreviated as GMC, is planned to be completed in the 2030s. It will have approximately 10 times the resolving power of the Hubble telescope, and at certain wavelengths about 4 times the spatial resolution of the James Webb Space Telescope. Its primary mirror has a diameter of 45.4 meters, which corresponds to a light collecting surface area approximately 368 square meter. Each primary mirror segment has a diameter of 6.5 meter and a thickness of 65 centimeter, and each weighs approximately 20 tons. The material is produced from a special low expansion glass. The mirror is manufactured by the Stewart Observatory Mirror Lab in the United States. During production, glass pieces placed into a giant rotation furnace are heated to approximately 1150 Celsius, and by rotating the furnace, the glass is shaped in the parabolic form. The cooling process of the meticulously prepared glass pieces takes months because rapid cooling called chaos cracks. Afterwards, the surface precision of the glass is measured with interferometers, and the margin of error is at the nanometer level. For surface smoothness, each mirror undergoes approximately 4 years of polishing, and this smoothness is millions of times smaller than a human hair. This telescope mirror produced beneath the football stadium of University of Arizona in America are manufactured as 7 segments and arranged in flavor petal pattern. Installed inside a closed automatic enclosure, even the moon alone weighs 21 tons, and funding has been provided to institutions from 7 different countries. 2. The Giant Magellan Telescope. Although the sparkling and bright light we see when we look at the sky may appear attractive to us, for an astronaut this is not desirable at all, because the brightness coming from those stars prevents you from seeing exoplanets or nearby galaxies, making the work more difficult. In addition, incoming light is distorted due to the shape of the Earth, and the obtained data may be limited or not completely clear. For this reason, the Hubble Space Telescope was placed above the atmosphere to prevent images from being destroyed by atmospheric layers, and the option obtain clearly images. Although this system was initially very beneficial and provided important photographs and data. Over time, system malfunctions and mechanical issues required repairs or part replacement directly on the telescope. However, since the Hubble Space Telescope and the James Webb Space Telescope are above the atmosphere, this is nearly impossible and very expensive. In fact, the expensive part of is not the maintenance or repair itself, but the telescope is a whole. Well, sufficient maintenance, repair, and the updates cannot be performed. Research on fixed point or must stop. Performing maintenance, repair, and updates above the atmosphere is both time-consuming and almost costly as building a new one. For this reason, there has been a return to ground-based telescopes. With ground-supported telescopes, updates, repairs, and maintenance are easier, less costly, and can be completed in a much shorter time. At this point, we should mention a system called the adaptive option used since the early 2000s, which made ground-based telescopes advantageous again. We can explain the adaptive optics system simply like this. Light coming from the cosmos travels perfectly and without distortion until it enters Earth's atmosphere. However, when it enters the atmosphere at about 120 km above Earth, humidity, gas layers, the shape of the Earth, dust clouds, and many other factors distort the light and can render the collected data almost useless. This is where the adaptive optics system comes into play. It precisely calculates and measures the distortion of the light before atmospheric interface and correct these errors. By flexing mirrors on the telescope, it eliminates the damage caused by error measurements and enables results nearly as clear as those obtained by the Hubble Space Telescope and the James Webb Telescope launched by foreign Earth. The superior technology of the mirrors and the data centers in this telescope also allow us to obtain results 10 times better than Hubble. Thanks to obtained optics, the nano-level expanding telescope glass processing the incoming light in a way that enables precise and accurate calculations. Neither vibration nor atmospheric condition can prevent its operation, while it also allows upgrade and technological improvements. The most exciting part is that it can operate coordination with both telescopes. It can work together with James Webb Space Telescope launched about 1 million miles from Earth. Based on the general data obtained from James Webb, it becomes possible to determine which areas the Magellan should focus on, enable faster, more efficient, and coordinated research. In fact, these telescopes and the new ones being built are not competitors. On the contrary, they are part of a system. We can think of their obtained efforts as forming one of complete telescope. It is says that Giant Magellan Telescope will be completed in 2030, and until then, intense works awaits the engineers. See you in another incredible design video. Thank you for listening.